Stephen. Thank you for letting me be here with you today. It's an honor. And I wake up every morning and say, what can I do to stop burning fossil fuels? And I thought, oh, today's easy. I get to speak to all these wonderful people who understand the problems and appreciate it. So thank you very much. So today, I'm going to talk quickly because we have a lot to go through. And I'm going to start at the 14-mile level at the outer atmosphere, and then get down to more and more specifics about what is happening here on Day 5 and what you can do in your own world, in your own home. So we start by talking about getting in your car on a cool day. Do you ever get in your car and it's warm inside, but it's pretty cool outside? Well, what's happening there is that ultraviolet rays pass through glass. They get inside the car, they warm up, they become infrared rays, which are too long and they can't get back out. So that's called the greenhouse effect. And that effect, we all feel it when we get in the car on those cool days. And we don't want to leave babies in that car. We don't want to leave pets in that car because it's dangerous. But the same thing is happening on Earth. 14 miles out, literally, is the outer atmosphere. And we're producing so much greenhouse gases. Carbon dioxide is one of the key gases of the greenhouse gas set. We're producing so much it's creating a blanket, so to speak, around the Earth and trapping air inside. And all of our babies and all of our pets are living here. And I personally don't want to leave them here in that condition. So we have seen the impacts of all of this, from heat to drought to storms, fires, and certainly the melting of the ice caps. One impact that you might not be aware of is shown by the two globes on the bottom. When we were kids growing up, we could pretty much depend on a pretty steady, stable polar vortex growing up. But because the heat differentials are changing between the equator and the poles, that vortex is now warbling, they call it warbling. And that's why some days you'll have minus 10 degrees here, and then the next day we'll have 60-degree days. That's what's happening. And that's what's happening more and more, and it's having a massive impact on the globe. So all of this heat that we're keeping in has been absorbed by the oceans. And another impact that is literally right around us is the acidification of the oceans right around us. It's impacting everything that live in the oceans. And one of the warmest bodies of water on Earth is the Gulf of Maine, and the bay here that we live on, Cape Cod Bay, is the southern part of that. So it is right literally in our backyard. The Cape Cod Commission has online a sea level rise viewer. We're looking here at 6 feet sea level rise, which is likely to happen in our kids' lifetime. And the impact of that is shown by the red dots. The red dots are all the critical buildings on the Cape that would be impacted. And the blue dots are a summary of our representation of the buildings that would be impacted. So 106 buildings in our area here will be impacted. So that means schools and police stations, care centers, things like that. Critical buildings that we need for our support. And if you look out here near Truro, you can see a lot of purple on this map. If we could zoom in closer on this, you'd see purple along in here as well. Over 30% of the roads will be flooded with 6 feet of sea level rise. And so we are in a very difficult situation here. And what we're going to focus on today is what you and I can do to fix this situation. And I always think if I talk to 25, 30 people, and they talk to 25, 30 people, and they talk to 25, 30 people, we could have 220,000 people understanding what the problem is and what we can do about it very, very quickly. So, what does it mean for Cape Cod to be producing carbon dioxide? If you took a pound of carbon dioxide and put it in a sphere, it would fill a sphere at about 23 inches. That's why we have the diamond exercise ball in the middle. Those exercise balls are about 23 inches in diameter. So On Cape Cod, according to the Cape Cod Commission study, we produce over 7 billion, that's with a B, pounds of carbon dioxide every year. So think with me, if you would, just for a minute, 7 billion exercise balls floating up from Cape Cod and filling the atmosphere. That's the problem. And that happens not once every 10 years, it's every year we're doing that. And that primarily comes from transportation. 55.5% is transportation, and 39.2% comes from buildings. My focus is on the buildings. There is a lot of work going on with transportation on the Cape, especially the large bus systems and things like that. There is work going on, but I'm all about buildings, so that's what we're going to talk about today. Across the globe, from the global to the federal to the state level, there have been goals set for what kind of emissions we need to reduce to pre-industrial levels. And we know that on a global level, the Paris Climate Agreement put out a goal of by 2050, 50% of the emissions should be reduced. On a federal level, because of the president we now have, by 2030, 40% reduction is the goal. On a state level, we're lucky to live in Massachusetts, in my opinion. By 2030, it's 50% reduction, and by 2050, they want to reduce carbon emissions by 80%. So imagine all those exercise balls, we want to cut them in half. We want to cut that in half, and we have to do that. If we don't do that, what will happen in many different ways, lots of different ways, and I get news feeds about this every day. What will happen is we'll hit tipping points with different aspects of what's going on Earth. The permafrost, for instance, if that continues to melt, it releases a great deal of carbon dioxide. The release of that carbon dioxide will cause it to melt even further. And on it goes, and on it goes, and on it goes. So the goal by the Paris Climate Agreement was to keep the Earth's atmosphere at 1.5 degrees centigrade. And we are inching toward that, and if not zooming toward that. We have to reduce our carbon dioxide emissions immediately. So we wanted to talk about green architecture today. And I always start with, we just need to get as smart as people who used to live here were. In the upper right corner of this slide is a picture of the Hotsey House. It's in Sandwich, it's right down the street. It's from the 1600s. And those old salt box houses don't face the street typically, but they do face south. So they knew what they were doing. Those big expanses face south, and that long sloping roof faced north. So it was putting its back to the north wind and putting its face to the southern sun. And they put the chimneys of these buildings in the middle, central heating, which emanated heat out. And in many of these buildings, the rooms right around the chimney were the rooms you lived in. And now they have adjunct rooms on the outside that were used for cooling and storage and things like that. In the south, by contrast, is shown on the left there. That's a plantation house. And you'll see on that house there's a lot of shading in all the windows. They knew what they were doing. They just need to get as smart as they were. So they put a lot of shading on their buildings. And they put the chimneys at the end. You see that? And if you open the front door, you could also open the back door, and the wind would go, they face their homes to the prevailing wind on the site. So the wind would go right through the home and up through the chimneys. So what they needed primarily was cooling and air conditioning, as we call it. We needed warmth and heat to survive. So they did it differently. And a lot of the principles that they followed then are the same principles that we follow now. One of the most outstanding examples of this is this, if this is the largest green building in Boston, it's called the Jenga building, for obvious reasons. It looks like that name, Jenga. And it's the EU Center for Computing and Data Sciences. It uses no fossil fuels whatsoever in its heating and cooling. It's all renewable energy. It relies tremendously on geothermal heating. And how many people here have a heat pump at their home? A lot. So a heat pump takes heat from one area, condenses it, and puts it in another area. So it can both take heat from outside, put it into your home for heating, or it can take heat out of your home, condense it, put it outside for cooling of your house. They're very, very efficient. It can be 300 to 400% efficient. For every BTU you put in, you get 3 or 4 back in value. This building takes heat from below the ground. It needs so much, it needs to boost up the amount of heat, and it needs it year round. So because it's on the flats, in Boston they had all those infill areas, and this is in the back bay, it's on the flats. I know from personal experience that the material that's under those buildings is this mucky stuff that they fill in with. And so you don't, unlike many of the yards, you dig in, you hit rock. That is not true on this site. It's mucky stuff that they drill down in. They have 139 pipes that go down into the ground. It takes 60-degree air and puts it into the building and condenses it so that it's a comfortable 70 degrees. And that works in reverse. If you start at 60 degrees, that's a nice summertime temperature to start with. So it's using that heat below, or cooling below the ground for this building. And you can take a tour of this building. It's really impressive and lots of fun to go through. One of the things that it has is the center light well. So how do you apply light and air to the center? And it has this fascinating stair that goes down the middle. That light pours in from every side and up above. So how do you build a green building? Well, you build for the site. And wherever site you are, you build primarily for that site. I was just in Santa Barbara, where they don't have to heat or cool virtually at all. They manage some humidity there, but it's really a very benign environment. But we have snow and we have warmth. And so these are just some of the things that you would have to do. You have to insulate. You want to seal your air. So the guy with the jacket on wants to seal up as much as he can to stay as warm as he can. You want to do the same with the home. And we have to manage snow loads. We have to manage the snow load is 4 pounds per square foot. We have to match that. So we have specific things that we need to do here in New England, and it would be different if we were in Santa Fe. But the idea is to take the site where you are and build to the site, making it as energy efficient as possible. So we have heating and cooling we have to do here. We also have to start really seriously thinking about hurricane proofing and avoiding flooding. So these big storms that are hitting us have a lot more moisture in them because the water underneath them is so much warmer, it picks up a lot more moisture. So many of the big storms, the problem is the flooding from the rainfall, in addition to the rain and the other issues that come with the storms. So how do you do that? There are best practices out there. And before we go into what the best practices are, I want to talk about what is net zero. So at the federal level, they've gathered together definitions of net zero, and they found 20 different definitions. And there's a committee working on which definition makes the most sense. And I've had a little bit of input to that committee. So the definition that I am going by, because of where I live, and you'll understand that by the end of this, is that no carbon dioxide is produced in the heating and cooling and conditioning of the building. So the building we're in here right now, with this lighting and with that air conditioning, is producing no carbon dioxide, this building. The barn is a different story. The barn has a gas heater it's producing carbon dioxide. We're working on that. So when you're building a new building or you're making a major renovation, here in Massachusetts, we have part of the building code is the Massachusetts Stretch Energy Code. And energy codes didn't even exist before 1973. Nothing in Massachusetts anyway. There were no definitions in the building code. It had to do with energy. And then the oil embargo happened. How many people remember the oil embargo? Remember the lines at the gas stations and all that? That's when I started doing this work. I'm doing it myself. But now we have this wonderful stretch code. And the new buildings that are being built over here are built to the Mass Energy Stretch Code. We talked about using LEED. We talked about using passive house, which are two other, you would call them definitions of what an energy efficient would be, a building would be. We chose the Mass Energy Stretch Code because the way it works, these all work a little differently. LEED works with, they give you a sort of checklist and you can pick from the different menus what you want to do to make your building efficient. My experience with LEED is it produces lovely buildings and then it produces some buildings that don't work well at all in terms of energy use. So that's my experience with them. Passive house is more stringent in my experience, and they work more on what is the envelope of the building, how is the envelope together, which is what I think is important. And that's exactly what the stretch code does. It really focuses on the envelope. We have an architect who worked on those buildings. She can not believe the stretch energy code and all the calculations you have to do to meet the criteria. So just know that there are different ways that you can approach a new building. And we're going to talk about what to do with the existing buildings. Because here on Cape Cod, these are numbers I pulled off the web. And I have sources for them all. If you have better data, let me know. But there are 165,000 housing units, as I understand it, 94,000 homes, and about 12 or so new homes are built in each town per year, on average. 51 public schools, 25 private schools. There are 4 acute care hospitals between the Cape and the Islands, many different care centers as well. 15 police stations, 16 fire stations, and about 5,000 courthouses. We don't have any industrial. We don't have fish processing here. It's very much a very residential environment that we have here in the Cape. This is a chart that shows when were houses built on the Cape. So on the left side, it says houses that are 1939 or older. So that first bar is 1939 or older. So the Hoxie House is in that category. The second category is 1940 to 1969. So in and around the war, that's when the houses were built here. Then we jump to 1960 to 1979, and then 1979 to 1999. So the two big bars, so most of the houses here, and I would say the buildings, are built in that time frame. And I just mentioned that the building code didn't even have anything having to do with energy from this point that way. So there was no energy code whatsoever for any of the buildings, for any building, and my house was built in 1955 that way. So no insulation, no ceiling on any of those buildings. And we have a lot of those buildings that we have to make energy efficient. So then we go up to 2000 here and then 2014 and later. So when you're thinking about how do you make an area like Cape Cod energy efficient, we're not building a lot of new buildings. So we don't have to worry so much about LEED and passive house and all those things. We have a lot of existing buildings that we have to deal with and that we have to work with. That's why here at Heritage, we have focused on taking the existing buildings including the one we're in, and making them the most energy efficient we can, and assessing each building individually for what could be done to make it more energy efficient and deploy solar if possible. So the buildings here, there are 18 in total on this 100-acre campus. 8 of them are the big users, 8 of the other things, like this building, the barn, a few others. In the upper left, that's a farmhouse from the 1600s. That's mostly administrative offices. The round arm, and this is called Holt, which is where we are now. There's a school on campus from preschool to grade 2. And I wish I was a kid and go to that school. Because they're outside 2 hours every day on this beautiful campus, and they do a lot of STEM education regarding that. Wonderful. And then we looked at things like the what we call the Welcome Center. This Welcome Center was built in 1955 to that level of code, and it was hit by a black locust in one of the big storms in the last couple of years, so it was not in good shape. It couldn't be saved. That's why we're building the new Welcome Center. It was also built for 25,000 visitors. We now get 125,000 visitors annually. And so we needed more space, literally, for people to enter, get reacclimated, and move on through the garden. At the same time, we instituted a sustainability plan that became part of the strategic plan at Heritage in 2019. In that plan, we took 3 basic steps. We measured everything. We measured all the buildings, all the land, 5-year energy use at the time. We're now up to 10 years worth of energy use. And we measured carbon dioxide. How much carbon dioxide is being absorbed back into all the plants here? And Susan was part of that process, one of the volunteers. We had 25 volunteers who came here and worked on that. Then we set goals. When we looked at all the goals, and we settled on the goals of Massachusetts, which is to reduce carbon dioxide emissions by 50% by 2030 and 80% by 2050. And from those 2 steps, we developed a conservation plan, and the heart of it was to electrify everything. So any place we were burning fossil fuels, we identified ways that we could shift it over to using heat pumps instead of gas burners, and deploy solar wherever possible. We studied every rooftop here, where can we deploy solar, and I'll talk about that. How do we measure things? So I start with utility bills. What are utility bills? They tell you how much you're using on the whole. And so we have monthly data for 10 years now of how much energy we've been using. That includes all the kilowatt hours, all the, for electricity, the therms for gas, gallons for gasoline, for vehicles. Oil was present here at one time, is no longer here. And propane was being used here, it's no longer. But we started with the utility bills. And that's what we've been doing with all the churches. We start with the utility bills. So then, how do you compare different types? How do you compare a kilowatt to a therm? Well, it's the same way you compare a cupcake to a rice cake. You use calories in the case of a cupcake to a rice cake. In the world of energy, we use BTUs. So all of that data was converted to BTUs. And this BTU comparison shows you at the time in 2019, 50% of the energy used, 57% of the energy used on this campus was electricity, 33% natural gas. There was propane used at the time, and definitely gasoline was used in some of the parts around. And this shows you over time. So on the left side is 2013, and this goes up to 2022. Just through energy conservation, this is a downward trend. The use of energy is going down. And this is just through energy conservation. So the yellow line at the top is the summary line of the lines below it. So that adds up all the lines below. The gray line is the electricity use, and then gas, and then propane. And this is a representation of the carbon dioxide as a result. So in this case, this red line, this is our line. This is electricity. This is gas. This is propane. And so propane drops off. Yes, we stopped using it altogether. And we started using more natural gas, so this line went up. Electricity, up to this point, was a downward trend just through energy conservation. So that's adding insulation, swimming in, doing all those simple things that don't cost much, and for which there are many incentives and rebates now. We were able to identify that we were able to cut the use of energy here dramatically. And then what happened here was we started purchasing solar energy off the grid. So all the electricity used was producing no carbon dioxide. So this building uses heat pumps, it's lit by LED lights, efficient computers, and it's powered by solar energy off the grid. So in this building right now, we're not producing any carbon dioxide, but we're very comfortable in it and able to operate really well. Since then, so this is 2022, our gas use went up. I was so depressed one day when I saw that line go up. So we analyze this every year. We wait till February of the following year and analyze the previous year. And our gas use went up. So our reduction to 50% is now flattened out a little bit, and we're more like 33%. But we are making some good changes that should have a big impact. This is a chart that talks about the sequestration project. And as I mentioned, Susan was too busy to we identified 5 plots on the property that represented sampling of vegetation. So some places had just flowers on it, some plots had trees and rhododendrons on them, other plots had just trees. There were 100 by 100 plots, and volunteers went in and measured every stem within the plot at breast height, so that's 4'3". If you measure that, cut the diameter of the tree, identify what kind of tree it is, and the condition of it. You can enter all that data into a spreadsheet or something, and 5,000 calculations later, they identified that we're sequestering 8 to 10 tons of carbon dioxide here every year. So that's a fraction of what we're using. So it helps us a little, but not a lot. But it is demonstrative of what is happening around us. There is carbon dioxide being absorbed into everything around us. Above the ground, on the ground, and under the ground, carbon dioxide is being absorbed. What was the best part of this project, I think, is working with the volunteers. They had a great time. They understood that they were part of this really important evaluation, and they helped us tremendously. So, and we worked with Wayne Walker. He's with the Woodwell Institute in Woods Hole. They're a leading analysis institute for global climate change. He was terrific. So, our motto here is conservation first. We all follow the impact on that line. So you go home and you call Cape Light Contact right away, have them come out to assess your home and tell you what are the things you can do in your own building to conserve energy. It makes you more comfortable, it reduces your expenses, and they have teams of people who can come in and do this at great incentive rates. I got $8,800 worth of work done on my house for $1,500, and it's even better now. And if you're a renter, 100% of that is covered by Cape Light Compact. So we highly recommend you have an assessment done. That's this team of people. They come out, they go through your house, they look at everything to determine what can be done to conserve energy, to emitting less carbon dioxide. So simple things like insulation, lighting, efficient appliances, many things. I have a checklist that I can email to you. You take for it. Here at Heritage, we also recycle, reuse, and rethink everything. This is Les Lutz, and he's the Director of Horticulture and Maintenance. And he's measuring the temperature of mulch. Back in the back 35, literally, there are piles of mulch that get moved from one pile to another depending on the temperature. So what the temperature does is it fills seeds in the mulch so they're not spreading around seeds and things like that. And he is absolutely terrific. Everyone here is completely on board with doing everything we can here. There are no synthetics used on any piece of the property. We manage water very carefully. On the left side, you see what's now cut out there. It's a bioswale, and you see it here. It takes water from the parking lot and diverts it into this area where there's a diffuser that diffuses the water out. There are bioswales as well at the Garden of the Senses. They're seen on that wooden walkway on the left side. You see these beautiful stone walls. And they're taking runoff from the hill behind it so that it doesn't go into the lake down below. So we have a lot of biospheres. And there's subsurface watering going on where needed, only where needed. And all the pumping of the water in the water column is done by solar. So a lot of attention paid to the water here. And we're electrifying everything. We're adding heat pumps wherever we can. We just now added a heat pump to that 1600-year-old house. So that's a big, wonderful change. You'll see EV chargers out front here. And the most popular thing on campus is this little fella. It's just a robot lawnmower. It runs on electricity. It's like the Roomba thing in your house. It goes back to its little station and it recharges. And we started only using it at night because people were so fascinated by it. They were standing around and filming it for hours on it, and kids would try to ride it. And, so we just went tonight. But it's a lot more efficient. It frees up staff time. So we don't have people out there mowing. There's no gas used in that. So it's all not producing carbon dioxide. We thought about naming it, putting a little tag on the top for a while, but then we decided to just go to the nighttime plan. So one of the things I've been talking about is how you can use electricity off the grid. We're lucky here in Massachusetts, we can do that. So this is an Eversource bill. The A item on the left shows you the usage. The B item shows you how much you paid for supply, and the C item is how much you paid for delivery. So Eversource is the delivery mechanism. They own all the wires to your house, and they manage the billing and your meters and stuff like that. They're the delivery system. This happened in the industry about 20 years ago. They split up delivery from supply. So now we can choose our supplier, and we can choose to have a nuclear power plant, buy our electricity if we want, or we can choose a wind farm or other renewable sources. You can make that choice. And that's what we have done here. And Cape Light Compact offers a very nice option through a company named Nextera. And you can purchase either 50% or 100% renewable energy. So all the electricity in your home or your church or your school is renewable, which is what we did here where that line dropped off so the air there. So now we do have new buildings that are going up here. There's a construction site. The aerial view shows you separate buildings. We had a design done before COVID, and it was all in one big building, all these functions. They're in one big building. And then COVID hit, and we realized people don't want to go into buildings, especially if they're coming to our garden. So we separated out the functions. So on the left, lower left is the bathroom area. On the right is the shop. Behind it is the ticket booth. And then the building set off at an angle there is in the information center. And so people arriving will be able to walk on this. It's a permeable surface that will be laid down there. So rainwater can go through it. so we don't have to manage all that watch-off area. Everything that we could use, we're reusing. There was a gate that was here on the grounds when Mr. Lilly owned it, way back when. We're reusing that gate, you'll see it at the front. And because of the separation of these functions, we'll be able to shut off different buildings at different times of the year. So it's a seasonal use here. So the bathrooms, for instance, won't be used all winter, so they'll be literally shut down. The shop will be shut down. There are a few offices in the center back building, but they're in a lower level. So they're really very, very efficient because on three sides they're burned with soil and they face out to the forest. And underneath the information building is a boardroom that is also burned and has a view of the waterfall. A few things about how this building is being built. So we wanted to try to get as many supplies as we could locally. And we wanted to face the building with stone to make it look like the stone of the barn here, to tie it in visually. And you notice that this building is just tucked into the environment here. There's no big stake in here. There's no big trophy. It's just tucked in and very functional and reflect what's going on around it. So that stone we found at the same quarry that the original barn stone came from, and it's in Norway. So it's very local. If you go out the hallway and look beyond the stairway there, you'll see a vertical metal strip. On the left side is the original stone, and on the right side is the replacement stone. There's a slight difference in them. One is greener than the other. But it's from the same quarry, it has the same look, and it certainly will look line that's over there, and the barn is over this way. The glass that we're using on this will be purple paint, because that's what we need to do to make that wall insulated now. And it will have a mesh on it that we can't see, but birds can see. So it's bird safe glass. So what they see is this mesh light coming. And we had a hard time inspecting this because we had to have the purple paint, and this kind of glass doesn't typically come in purple paint. But we found a way to make that happen. They're great architects for everything. Okay. We also are using this product called a quail wood. It's a pine that's been acidified, and it's good for 50 years. You don't have to touch it. No paint, no upkeep. It will come in as a beige color and will gray out, much like the shingles here on your cape. So again, that will kind of reflect the local building environment here. And all the trees that were removed for this site were sent to Maine and burned for energy in a plant up there, and will be replaced by one or more trees when all the landscaping is done. You'll notice that there's a pathway down the back, and many of the trees that are part of this new planted program are lining that path. So this is a checklist that I'd like to email to you. It talks about everything that we're doing here on these grounds. Conservation first, electrify everything, deploy solar. Those are the three big things that we need to do here on Cape Cod. We have many more existing buildings than new buildings. So our focus needs to be on what to do with our existing buildings. And we can contribute a great deal. We're producing 7 billion pounds of carbon dioxide every year. I'm confident we can cut that in half if we get to it. And so that's my presentation. Any questions?
This is still just out of curiosity, booth design, how can that be redone for energy efficiency?
So
I mean, if I could just finish for 1 second, I saw something years ago, and it was based on a natural design. I think another parts of the globally to put air, too loose and putting air box in there. And, then it's an air pocket where it could, basically in the summer wouldn't get so hot and in the winter, this is an efficient air design with natural flow.
Yeah.
And basically it was natural air conditioning that you just used in other parts of the world. And I was touring it, because you got everything there, but I'm thinking roof design, we're about to, maybe say, what can be done about that? Thank you.
So the heat pump question, it used to be, when I was a kid, heat pumps didn't work so well up here, because they had to have 30 degrees outside constant temperature. Now they work down to -15. That's product that's available now. There's a study going on at DOE working on heat pumps to work at -35 degrees centigrade. So they want them to work on the poles. The efficiency achieved from them comes from the fact that you're moving heat, not creating heat. So you're taking it to one place and moving it to another place. When you're burning gas to produce heat in particular, you're creating heat, and that produces a lot of carbon dioxide as a result. And that's the efficiency differential achieved by heat pumps. As to an air pocket and a roof, it does sound like a great idea, and there are air baffles that you want to put behind insulation so that allow air to pass through. Air is a good barrier, but it has to be perfectly sealed. And so the reason we're done with triple last year, those seals will be very tight. They'll be, they meet industry specifications. So an air pocket can help, but it has to be super sealed and tight. And it would only be, in my opinion, on a roof only, and not in my little 1955-year-old house. I don't think I could play that so easily. Putting insulation there is a lot easier and doesn't.
I was intending that, sorry. I was just going to make a practical comment on home heating, moving to a heat pump, which I did last year, but just as a homeowner for 20 years on the Cape. 4 years ago it started to get a little hotter, a little more humid, and I looked into central air. Kind of was thrown back by the price and whatnot. But, so 2 years ago I looked at, with the incentives, a heat pump. With the incentives, it was the same price. So now I'm getting heat and AC.
Right.
Most of it's tucked away nicely, and there's some split systems, and it's at 0%. So it's literally a no-brainer, and it was, if you haven't asked them the question in a few years, look into it again, because those incentives are real. And it's about 15 minutes in the bank, and that was it.
Yeah. And there are 0% interest loans now available for 7 years, up to $50,000 from Cape Light Home Back. That's free money. We installed heat pump on our house, and now there's solar. Because solar panels, when we first moved here 5 years ago, solar panels were at 200 watts per panel. Now they're at 470 watts per panel. So that differential for us, because of the orientation of our roof, no big difference. So we just installed them. And in the case of the heat pump, we didn't get the kind of incentives you have now. We're incredible. We get $10,000 back by installing a heat pump. And so there, on the back side of the sheet that I have is a link to all the different rebates and incentive programs that you can check for this kind of work. So we're not paying any electricity bills at our house, and we have heat and cooling building. Jane.
Just citing you here, you talk about all this and what's going on in Heritage, and thanking Judith for her help at our church, the Unitarian Church of Barnstable down the road. We called her in because we got nervous with a January heat bill going up, and so she sat with our building committee and went through what we had done since putting solar on the church in 2017, and with her help and more insulation and energy efficiency and switching to a few heat pumps in some of our areas, we were able to bring our bring our energy use down 50% over 5 years. And since then, the last couple of years, we're now down 60% from when you first analyzed it. So it's huge. It is a huge deal. The solar helped. Must have been an act of God. It happened right before I came here, but it's the first solar panel that faces the Old Kings Highway. And I don't know how we got that done, but we did. And just solarizing, it works some magic. The double roof thing is kind of interesting, and just from being a solar PV advocate, if you put solar panels on your roof, you're creating a little of that effect, Patrick. And in fact, we asked some of the professionals in the field, what benefit does that give us for cooling? We've had solar in Texas as well as in DC, where cooling is a much bigger need even than here, and they say about 10% savings because you're shading your roof.
Right.
And the other thing solar PV does is it protects your roof. Your roof doesn't age as fast.
Right.
So some insurance companies will even give you a break on the aging of your roof. So that's interesting. And we are helping our daughter get a tiny house, a very green tiny house designed for Sacramento, and they are building a double roof.
Yeah.
The green builders out there, it's already 105 degrees there this week with this heat dome, and so it's going to really be important for the cooling.
Right. Yeah, that's it.
Yeah, and I'm wondering what non-financial barriers that you're running into. For example, in Centerville and Osterville, we're getting pushback on the installation of the electrical lines from the wind farms. Are you seeing anything like that, and then how do you approach those?
So I've been in this for 50 years. I was in Washington DC when Jimmy Carter put panels on the White House, and I was there when Reagan took them away. And so pushback has come in many different forms over time. And what I observed over that time is that it all met the way eventually. All the pushback seems to melt away as people gain more understanding about what's really going on and what we have to do to address this issue. And the immediate threat that it poses for us, not only here now, but certainly for the people we leave behind. So yes, there's pushback in all kinds of forms. What helps it is just to continue to talk about the facts of what's happening. And as I understand it, the facts about the line coming onto that beach are going to have virtually no impact. You don't even know they're there. And they're so deep they won't have no impact whatsoever. So there's always seems to be this flurry of worry around change. And a lot of it is change management. And the more and more that we're 25 people go out, 25 people and say there's no worry there in Fayetteville Beach. That would help tremendous amount. And we have to do this. We actually, if we want our Earth to continue to support life the way we've been used to, we have to do that.
Okay, one other observation. Over the years, I've done some energy management control work, and one of the problems I ran into were the HVAC dealers that just were, in general, they were good people, but they were so limited in how flexible they could be. They'd get trained on one manufactured equipment and didn't know what to do with mine.
Yes.
And I don't know if the cake is like that and why.
I think the building industry as a whole is a recalcitrant industry. They like to stick with what they know. And there are very many better solutions that are out there now. And kind of the last people to get up on board with it all is the building industry. And there has been a lot of pushback on the energy code here, for instance. and it's primarily from the building industry. But then the tobacco industry put back on smoking, and the gas industry does this natural gas, which is really methane, is okay for us. And there's a lot of big players involved that present recalcitrant responses to what is needed. And you just have to keep moving forward and keep moving forward. And I depend on my friends here to keep me moving forward. Because I wake up every morning and I have many news feeds that tell me what the problem is, and I know what the solution is, so I need to just get out there and talk about it. And there are some good, Cape Cod Heat Pumps is a very good company to talk to with it. What is it? Pumps. Cape Cod Heat. And I don't listen to any companies, but that's what I've heard. Yeah.
Thanks for the great presentation. I just moved here and I'm starting to learn about the historic and conservation requirements, and I live in a historic conservation area. And so when you talk about dependencies relating to those aspects of where we live, particularly if I want to put solar panels and it's visible from a public way and things like that in a historic area, do you have any thoughts on that? Thank you.
If your historic area is in Sandwich, you have no problem. They do not get in the way. I live in a double historic area where I'm right downtown in Sandwich here. And we have no issue whatsoever from historic. Other towns are different, and it's town to town here. And at the state level, Judith Sear has introduced a bill that will prevent any historic committee from superseding energy decisions of that. So where do you live?
East Sandwich Beach.
East Sandwich? Oh, no problem. There's absolutely no problem here in Sandwich. So that's good. Yes.
Quick comment on
I'm
that.
with it.
What about? Okay, hi. My first time here, I'm really impressed with, the organization and the messages that you're conveying and the way you're doing it. I tend, as I get older, to be so much jaded and frustrated with what the hell's going on around us.
Imagine why.
Yeah, I know. And let's not get into politics. But what I'm concerned about, to pick up on what you said about the building industry, lagging, there's one element that I was thinking before you brought that up that's part of that. And I've lived on the Cape for 40 years. How do you motivate the contractors, the guys and gals, probably mostly guys, I can be very candid, that are the craftsmen, tradesmen, from covering their butts to save money, to put up camouflage effect that they are satisfying the contractors and the builders' requirements when indeed they're not taking shortcuts. And it's not a perfect world, I realize that. But how, from your perspective, and it's a process, I understand, how do we, I guess, as paying these guys and gals, right? What are the options that we can put teeth into, like, making sure that it is being built to code?
So I've worked with hundreds of homeowners on renovating their homes in different towns. And the inspectors and the interactions that they have with builders varies dramatically, depending on where you are. I think it's more the inspector who has to step up to the plate. And you as a homeowner need to rely on that inspector to do the right thing. But that requires of you now, with this energy situation, is to understand what that Mass Energy Code is about. And it's not all that hard. There's a lot of online free training on it. Or you could call someone like me and I could come in and just go through quickly and say, look for this, look for that, look for that, this should be this way, that way. There are people in this audience who can help you with that. So it's a very naturally tense relationship between builders, homeowners, and inspectors. And the inspectors really will be the ones on top of it. And sometimes they're just terrific, and other towns not so much. So I don't know if that answers your question, but if it comes from the energy issue, I'm always happy with it when they give it walkthrough. I did that in Sue's church.
Judith, I know Eversource has a big geothermal project in Framingham.
Yeah,
Did you think about geothermal here?
yes, we did.
And secondly, did you think about roadside range here?
On-site wind.
On-site, well, yes. Okay. Yes, we did think about geothermal. We evaluated the building load of the new buildings and the seasonality. They don't have heat through winter in those spaces here. And we felt that definitely there are air source heat pumps as opposed to ground source heat pumps that are effective enough for this environment to work here. So a heat pump is measured by the amount of air conditioning it puts out or the amount of heating it puts out. Seasonal energy efficiency rating, kind of like miles per gallon for your car. The SEER number, seasonal energy efficiency rating, on many of the heat pumps were good enough that we went with the air source heat pumps. They're a lot less expensive to install, even though if you look out there, it's all sand. We could drill down very easily here. And so the cost differential made air source heat pumps the way we went here. And then, what's the other question?
Sure.
Oh, wait, oh, yeah.
On-site.
We live in a neighborhood, and we have thought about wind. There is 35 acres that's not even touched over here that backs up to another neighborhood. And we analyze wind, but we also analyze deploying solar on site and purchasing it off the grid. And again, financial reason, deploying photovoltaics here and purchasing off the grid financially run out and could do the job. We wanted to get the job done at the lowest possible cost. So that's what we want to do. Yeah, good trust and so. There are new small egg beater kind of wind machines that you might think about on this building, but I'm not sure.
Well, Judith,
Yeah.
thank you so much. We're at time, so I just wanted to kind of wrap it up. Great discussion. We're not running anywhere, so as usual, we'll be around and we can have a little bit more Q&A. Just a couple of quick things. I always get the last word, and I like that. So, and I like to embarrass people, as people who know. We do have Mariel Marchand here from Cape Cod Compact. She's not the person who manages all of the energy efficiency work, but I'm sure she can put you in touch with the people in the organization who are. They are a sustaining sponsor of ours and very well.
Great work.
We work with. And I'd just like to also add, to Elvin's point, so the Sierra Club, for those of you may not know, is holding a rally on June 15th at Craigville Beach. And I encourage you all to turn out. The whole issue of the wind energy, everybody wants it, but not my backyard. I mean, it's another story. We need it. It's the right place for it. It's the right way to do it. As Judith reiterating, it's underground. You get more radiation from the electrical wires in the building. So anyway, thank you all very much for coming. Grab some more coffee and Snowy Owl pastries. Thank you so much.